Everyone, and welcome back. In this lecture, we'll continue our discussion on decision trees and random forests. We'll consider a larger dataset to build our models and evaluate them. Here we have another dataset called Lending Club New Data. We'll start by importing it and then looking at the dataset. For that, we'll use pandas read CSV method, and I'll pass the file name, and let's save it in a variable called loans. Let's check out what it looks like by calling the head method. So here we see the first 5 rows, and our dataset has 24 columns. Previously, we saw that our dataset has 7 columns, but this one has 24 columns. So we have additional columns. And this is the same dataset regarding whether the person will get a good loan or a bad loan, but we have some more features. For instance, employment length, subgrade number, payment increase ratio, and so on. So we'll use all the new columns as our features, and we'll try to determine whether a person will get a good loan or a bad loan depending on these features. Okay, the only difference is here we have a bigger data set, we have more rows, more data points, and more features to consider. So for that, if we call the tail method loans.tail, we have about 9,500 rows. The previous one had only less than 1,500 rows. And let's call the info method. Okay, we see that we have 9,116 rows and 24 columns. And here you have name of your columns, and the size of the file is about 1.7 megabytes, much larger than our previous dataset. Okay, so these are some information that you can get from your dataset. We'll do the same thing that we did for our previous dataset. We'll start by adding a new column known as good columns, and we'll map it with the bad columns values 1 and 0. We'll set 0 as yes and then 1 as no for our new column good loans, and we'll use our good loans as our target, whereas we'll use all these remaining columns as our feature. So let's add our new column known as good loans, good underscore loans, and we'll set that to be equal to, we'll take our bad loans and apply the lambda function. Okay, so bad loans, and you can call the columns method if you want to see a list of all the columns, and then simply copy those column names and paste them here, and if you don't want to type them, of course. So we have our bad loans, and we'll call the apply method, and we'll use the lambda function. We can say lambda y yes if x is equal to 0, or else we'll set it to no. Oh, sorry, this should be y. We used y. Okay, so lambda y, set it to yes if the value of y is 0, or else set it to no. Okay, now that we have added our new column, good loans, we can check it out by calling the head method on our loans data frame. And here we see that a new column is added. Whenever the value of bad loans is 0, the good loans value is yes, and whenever it's 1, the value is no. Next, let's define our features and target. As I mentioned, for our features, we'll use all the column except for the good loans and bad loans columns. So let's drop those 2 columns by calling the drop method on our dataset, and simply pass the 2 columns as a list. So bad loans and good loans, good underscore loans, and we're dropping the axis, we're dropping the column, so we'll pass the axis attribute and set it to 1. For our target, we'll use our good loans column. Next, we can check out the shape of our x and y features and target. So let's print x dot shape and y dot shape, and we see that our features is two-dimensional, 9500 by 23 rows, whereas our target is 9516, one-dimensional. Okay, now that we have defined our feature and target, we can use the train test split method to split our dataset into training and then testing datasets. After that, we can instantiate our decision tree classifier model and train that model with our training datasets. And later we'll use the testing datasets to make predictions. That's what we'll do next. Okay, let's start by splitting our dataset, and we'll save them in the variables xtrain, xtest, ytrain, and ytest. We have done this before. Xtrain, xtest, ytrain, and then ytest. We'll set it to be equal to train test split, and then we'll pass our x and y datasets. And for test size, we'll pass, let's use 30%. If you don't pass that, the default value will be used, and we'll pass a random state of 124. So I have already imported the train test split method in one of the previous lectures, but if you haven't done so, import the train test split from scikit-learn's cross validation. And if you want to get the same result as me, you can use a random state of 124. Otherwise, you can use a different random state. So now that we have split our dataset into training and testing datasets, we can print out their shapes. Let's print out xtrain.shape and xtest.shape. So our xtrain is 6600 by 23. So this 6661 is 70% of our dataset, since we are using 70% of our dataset for training and only 30% for testing. That's why our xtest is 2855, which is 30% of 9516. Similarly, if we print out the shape of ytrain and ytest, we'll get the same result, except they both will be one-dimensional, but the split will be 70% and 30% of our dataset. Okay, now that we have split our dataset, it's time to instantiate our decision tree classifier model. Decision tree classifier. That's our model, and we'll save this in a variable called, I'll save it in a variable called model2. And now that we have instantiated our decision tree classifier model, we can call the fit method to train our model by passing our xtrain and ytrain datasets. And these are the default values that our model uses. Again, you can check it out on the documentation. Next, let's predict by using our testing datasets. So we'll call model2.predict and then pass our xtest dataset, and we'll save our result in a variable called prediction2. Next, we can print out or evaluate our model by calling the confusion matrix and classification report. Let's do that. Let's start by printing the confusion matrix. We'll pass our ytest dataset and then our prediction2 that we just calculated. So let's run this. Okay, here we see that only 12 plus 9, about 21 of our dataset is misclassified. Those are the false positives and false negatives. Only 21, right? Even if we have a larger dataset, only a few of them are misclassified. And if we print out the classification report, let's pass ytest and prediction2 and run it. We have a much better classification report accuracy, an average of 99%. And if you look at it, for each of the good loans values, when it's yes, we have 100% accuracy, whereas when it's no, we have 98% precision, 97% for recall, and 98% for F1 score. So our model did very well, and we can tell that from the confusion matrix and classification report result. And if you ask why our model did better this time, one reason is we have a larger data set, and we trained on, our model was able to train on more data sets, right? So here if you see, we were able to train on more than 6,000 data sets, whereas our previous model only learned on about 900 data sets. And since we considered more columns, more features, we were able to get a better precision, recall, and F1 score. That's because, this good loan or bad loans is influenced by just more than a few columns or a few features. So all these features play a crucial role in determining whether a person gets a good loan or a bad loan. Okay. In our first model, we only considered 7 of these features, whereas in this model, we considered 23 features or columns. Okay. So that's another reason why the second model did better than the first model. Great. What we'll do in the next lecture is build a random forest classifier model and check out the result. You can guess that the random forest classifier model will most likely do very well, and you won't be able to see the difference between those two, since this one already has a 99% accuracy, and as a model, even if we get 100% accuracy, average accuracy, both models did pretty well, and it will be very hard to distinguish the differences, right? So we'll see that in the next lecture. Thank you, everyone.